All right, so I'm going to go over in a little bit more detail what we saw in the video, but these are what the notes would look like from class. This is what you'll need to know. I will send everybody a copy of the key after this week. So real numbers, this is going to be all numbers, like we said up top. Now, if I scrolled up, you would see it at the top, but there wasn't enough room, so I chose to do this and just write it for you so you can see. So irrational numbers, those are going to be the decimals that never end and have no repeating pattern. And that's going to be represented with an I. That's a number like pi, 3.14, repeating forever. You took the square root of 2. It's a long decimal with non-repeating numbers and never ends. And the same with the negative square root of 101. You would have the same types of non-repeating decimals after both those if you put those in a calculator. So how about rational numbers? That's going to be represented by a Q. You know what? I'll go ahead and fill these in while I'm talking about that. But rational numbers, so all fractions and decimals that either end or have a repeating pattern. For example, 1/3 is 0.33333, and it just repeats forever. It's predictable. We know what's going to happen. You also have a decimal like that, negative 0.67. That's a rational number because it ends. We know where it ends. There's no repeating decimals. Square root of 16. So you might be asking, okay, well, how come there's the square root of 2 is irrational? The square root of 16 is rational. Well, the square root of 16 is 4. Therefore, making it, which we'll find out, an integer, a whole number, and a natural number as well. So let's talk about the other three. So natural numbers are like 1, 2, 3. What's a natural number? Think about when you're counting, right? You don't start at 0, you start at 1. 1, 2, 3. You don't have 0 of something, you just don't have it. You could have 1 of something. That's where natural numbers come from. So then you have whole numbers. The only difference here is that the 0 is included. And integers, it's all whole numbers and their opposites. So -2, -1, 0, 1, and 2. Now, do these overlap? Of course. So in the video, it gave an example to remember. We're going to forget about irrational for a minute. So let's pretend it's a rational number. Think of it as this. You know, the natural numbers are like Harrisburg. Whole numbers, we're going to say that's PA. Integers, USA. Rational numbers, North America. Real numbers, Earth. So can you be in PA? Can you be in Harrisburg and not be in PA, USA, North America, or Earth? No, you're in all of those things. If you're a natural number, you're going to be all of those other things. But could you be in Pennsylvania and be in Pittsburgh? You're not in Harrisburg, right? But you are still in the USA, North America, and Earth. And same with above. You could be in North America, you could be in Canada, and not be in the USA, not be in PA, not be in Harrisburg. That's kind of how these numbers work. One can be the other, but it doesn't necessarily mean the other is also it. I'm going to post another video with some examples of naming the sets of numbers, which you will do in an activity later in the presentation.